Alright, welcome to checkpoint 26. I'm going to start at the very last question for help. Consider the following two circles. The segment D1 is diameter of circle A and segment D2 is the diameter of circle B. If D1 equals 2 and D2 equals 2R, and if C subscript B denotes the circumference of circle B, so circumference of circle B, which of the following equations is true? 1 over 2r equals pi over the circumference of B. 1 over 2r is equal to 2 pi over the circumference of B. Or 1 over 2r is equal to the circumference of B over pi, and 1 over 2r is equal to the circumference of B times 2 pi. So the first thing I'm noticing in all of these is that on the left-hand side, they have the ratio of diameter 1 compared to diameter 2. And I'm noticing in the right hand of every equality that the circumference of B is on that. So the first thing that I'm going to think of is to find what is the circumference of circle A. And the way I remember circumference is by a little saying, cherry pies delicious. So circumference is equal to pi times the diameter. Since the diameter in circle A is 1 unit, we can say that the circumference for circle A is equal to pi times 1, and pi times 1 is equal to pi. So the circumference of circle A is equal to pi. So I'm going to look for a ratio that has diameter 1, which is in reference to circle A, compared to diameter 2 is going to equal the circumference of A compared to the circumference of B. And by substitution, since the circumference of A is equal to pi, we have pi for circumference of A. Diameter 1 was 1 unit long, and diameter 2 was 2r. So I'm going to look for the equality of 1 over 2r is equal to pi over circumference of B, which is 1 over 2r is equal to pi over circumference of B. The first one. So then, question 9. A regular 16-gon is inscribed inside a circle. The 16 congruent triangles that make up the 16-gon each have a base of length b and a height of h. Which of the following statements is true? So I'm going to pause here and notice that the 16-gon base doesn't completely follow the outer edge of the circle. There's just a little bit of white in between there, so the area of the 16-gon doesn't completely cover the area of the circle. So then the area of the circle is equal to pi h squared. The area of the circle is equal to 8 times b times height. So 8 times the base times the height. The area of the circle is slightly greater than 8 times the base times the height. And the area of the circle is slightly less than 8 times the base times the height. So the area of a triangle is equal to 1/2 its base times its height. And since there are 16 of these, the approximate area, the area of the 16-gon, so the area of the 16-gon is going to equal 16 of the areas of our individual triangles that are made up. So 16 times 1/2 times the base times the height. Now when you're multiplying, we can combine our numbers. So 16 times 1/2 is equal to 8 times the base times the height. So the area of our 16 gon is 8 times base times height. And this, like I said earlier, the 16 gon leaves a slight area between the base of it and the circumference of the circle. So the area of the circle is going to be slightly greater than 8 times base times the height. Okay, question 8. A regular octagon is inscribed inside a circle. The circle has a radius of 10 units. What is the approximate measure of the perimeter of the octagon, and what is the approximate area of the octagon? So in my head, I am visualizing a circle, and I know an octagon has 8 points and it's regular, so they should be the same distance apart. And I struggle with drawing octagons. 1, 2, 3, 4, 5, 6, 7, 8. So that's how I would draw my octagon. And you notice we had a radius, so from the center to any point on the edge of our circle, and the vertex is a vertex of an inscribed octagon would hit the edges of our circle. So my drawing's not extremely accurate, but you have the idea. So this is 10 units, and if I were to connect to an adjacent vertex, that would be another radius, which would give us a length of 10. And now I could find the area, this angle right here, which is 45 degrees. And how I know that is if we had 360 degrees, since we have 360 degrees in a circle, and I could copy this triangle 1, 2, 8 times. I could make the same triangle right there, right here, right here, right here, and right here. So I'm making 8 copies of that triangle, so I need to split my central angle by 8, which is equal to 45 degrees. Since I'm looking for this side length opposite, my angle, and I have the 2 adjacent sides to my angle, I can use the law of cosines. So I'm going to remember the law of cosines by thinking of, do I have side angle side, side angle side, and am I looking for the side opposite my angle, which is right here? So yes. So the law of cosines I remember generically as c squared is equal to, the side length adjacent to our angle plus the other side length adjacent to our angle minus 2 times the side length times the other adjacent side length times cosine of 45 degrees. And then I can type that into my calculator, which I already did, and I made sure it was in degrees. So we had 58.57. And that's equal to c squared. Now I just need to find c, my missing side length. So I'm going to square root it, since that's the inverse operation of a square. So the square root of c squared is equal to c. That's going to equal, let's take our square root of 58.5786. That's equal to 7.65. And now the question wants us to know the perimeter. So we just found this side length of our octagon. And since it's a regular octagon, I know that regular means that all of the side lengths have to be the same. So there's going to be 8 of those. So the perimeter of our octagon is going to equal 8 times 7.65 approximately. So 8 times 7.65, which is 61.2. So approximately 61.2. And the reason why we use approximately is because we rounded our decimals instead of letting them continue on forever. So the perimeter of this octagon is about 61.2. So that's A. And then B, what is the approximate area of the octagon? The area would be 1/2 base times our height. So our base would be this side length in that's connecting the vertexes, which we just found was 7.65, and the height would be less than 10 because the height, the 90-degree segment that would come down, our height of our triangle, wouldn't hit at a 90-degree angle. So to find our height, since we know that it's not going to be 10 exactly, we can find what the angle measure is of one of these interior angles right here. And we know that from our center to the vertex, it will split the octagon angle at that vertex in half. And an octagon angle has an angle measure of 135 degrees. So if we find half of 135, it is 67.5 degrees. So in this little triangle right here, this would be 67.5 degrees. I'm going to draw that triangle out over here. So this is the height right here that I'm drawing. This we found to be 7.65. And this angle right here is 67.5 degrees. And we do know from the center to the vertex of our octagon is 10 units because it's a radius. So if I'm looking at this, since I have a right triangle, I can use our trigonometry function, our trig functions of sine, cosine, and tangent. So I'm going to ask myself, okay, I want to find h, and I have this angle. So according to the angle of 67.5, I want to find my opposite side, and we have the choice between the adjacent side and the hypotenuse. We want to use the one that is as exact as possible, which is the 10 units, because we did round our length, our base length. So we have our hypotenuse. So then I'm going to ask myself which trig function has the ratio between the opposite side length and the hypotenuse side length, and that is the sine. So we're going to find the height by using sine of 67.5 degrees, and that's going to equal our height over 10. And I'm going to pause right here because I actually noticed a statement that I made that is incorrect. This length would not be 7.65 because it's not the full distance from vertex to vertex. It happens in between. So we actually wouldn't know our adjacent side. So then that really does just leave us the hypotenuse because it was our radius. So since sine of 67.5 degrees is a number, I'm going to leave it as is. I'm solving for h, and h is being divided by 10. So I'm going to use the multiplication property of equality. Multiply by 10, multiply by 10. So I'm going to have 10 sine of 67.5 degrees is equal to h divided by 10 times 10 is 10h, since we multiply numerators, divided by 10, and the denominator for a whole number is always 1. So 10 times 1 is 1. 10 divided by 10 makes the form of 1. It reduces down. So we have 1h is going to equal 10 times 67.5. So I'm going to go over to our calculator and make sure it's in degrees. Type in 10 sine of 67.5. That's going to equal 9.23 approximately. So I should change this to an approximation, 9.23. And that's just to find the height of our triangle. Now if we notice our triangle area, if you remember back, is 1/2 base times height. So the area of our triangle is going to be 1/2. What is our base? Our base in our triangle, from our center point to the vertex to an adjacent vertex back to our center point. This base right here we did find to be 7.65. So it is going to be 1/2 times 7.65 times the height, which we found to be approximately 9.23. So I'm going to type that into our calculator, and we have 1/2 times 7.65 times 9.23. It equals 35.30. Now notice our octagon is made up of 8 of those triangles. So we have the area of our octagon is going to equal 8 times the area of our triangles, which by substitution is going to be 35.30. So I'm going to multiply that by 8, which comes out to be about 282. 282.43. So then we're going to back to course player. It's about 283. It's a good approximation of our octagon. So then I'm going to give you the help for your video, and this one is to help reduce your stress levels, reduce any anxiety you're feeling, and it's to massage your ears. So just massage from the top all the way down to the bottom, to your earlobes, back up, all while you're taking deep breaths. And breathing is a really big key to help reducing your anxiety or stress level because it oxygenates your blood, and so then your body can function properly because it has an increased oxygen supply coursing through your body. So massage your ears for a couple of minutes or 30 seconds, however long, until you feel your levels reduce. Question Question 7. A regular hexagon is inscribed inside a circle. The circle has a radius of 12 units. That is the same setup except for it's a hexagon. So I would recommend Googling regular hexagon angle measures because you're going to need that in order to find your height, and then follow the same steps we did for question 8. Question 6 is set up very similarly to question, I want to say it was question 10. And question 9. Question 3 is set up like the question 10, comparing the ratios. So question 3 I will cover since it's a proportion. So consider the following two circles. Segment D1 is the diameter of circle A and segment D2 is the diameter of circle B. If C sub A denotes the circumference of circle A and C sub B denotes the circumference of circle B, which of the following equations is true? Diameter 1 times diameter 2 is equal to the circumference of B times the circumference of A. Diameter 1 times the circumference of B is equal to diameter 2 times the circumference of A, or the circumference of B is equal to diameter 1 times diameter 2 times the circumference of A, or diameter 1 times the circumference of A is equal to diameter 2 times the circumference of B. Since we know all triangles are, not all triangles, all circles are similar, we can set up a proportion. So we can say the diameter for circle A compared to the diameter to circle B is going to be equal to the circumference of circle A compared to the circumference of circle B. Now, I do not see any of those, but I do see ones that, so how do I move these out of the denominator? We're going to treat them just like we would a number. So to move diameter 2 out of the denominator, I'm going to use the multiplication property of equality and multiply by D2. So diameter 2 times diameter 1 divided by diameter 2 is going to be diameter 2 times diameter 1 divided by diameter 2. That's going to equal circumference of A divided by circumference of B is equal to diameter times diameter 2 is going to be circumference of A times diameter 2 divided by circumference of B. Now on this left-hand side we have a form of 1, so we can reduce that out since diameter 2 divided by diameter 2 is the same number. It does reduce down to 1, so that gives us 1 diameter 1 or just diameter 1 is equal to the circumference of A times diameter 2 divided by the circumference of B. So now we're going to do the same thing to move the circumference of B out of our diameter. We're going to use our multiplication property of equality times by circumference of B times by the circumference of B. So circumference of B times diameter 1 is just circumference of B times diameter 1, and that's going to equal circumference of A times diameter 2 divided by circumference of B times circumference of B is going to be the circumference of A times diameter 2 divided times the circumference of B divided by the circumference of B. Since we have two terms that have the same in the numerator and the denominator, we have a form of 1 which can reduce down. So circumference of B divided by circumference of B is a form of 1, so that can reduce down. So then I would be left with circumference of B times diameter 1 is equal to the circumference of A times the diameter of 2. So that is something that was an option. We had diameter 1 times circumference of B, which is what we have on our left-hand side. They just used, I want to say, the associative property where you can switch the order of multiplication, is equal to, they have diameter 2 times circumference of A times diameter 2. That's the same thing. We can trade it over. So there is your question 3. And again, look up for your hexagon and pentagon what the angles would be before you get started. And follow the same steps we took for solving question 8.